Hi everyone, welcome to this lesson on some applets that will really walk you through a very hands-on approach for you to correlation as we continue on in our study of linear regression. So there's going to be 4 that I'm going to walk you through. I strongly encourage you to play with these yourself. Some of them do run on Java. Actually, I think most of them do. So if you are on a Mac, I would highly recommend using either Firefox or Safari. On a Windows-based computer, it should not matter which browser you use. However, if you are having difficulty running some of these applets, I would check your Java settings under your control panel. You might have to turn down the security settings under your Java icon in the control panel. Same might be true on a Mac. On some of the older Macs, you might have to do that. So otherwise, maybe get ready to take note of what some of these URLs are. Again, there are 4 that I'll be walking you through. So the first one comes to us from Texas A&M University. This is a really great applet that will show you a great visual of a certain correlation coefficient and what a corresponding scatter plot might look like that would have that correlation coefficient. So you can see the URL there if you want to jot it down or copy it over and open your own browser and try this. I have them all set up for us so you can see what they do. So this is that Texas A&M one. You'll notice that it's preset there on the right to a correlation coefficient. Remember, that's what lowercase r is, to 0. So hopefully you remember, 0 correlation coefficient, typically your points in the scatter plot are all over the place, sort of as this one is. So what you can do with this applet is, if you move the slider there that you see underneath the R start moving it to the left, and you'll notice that the points in the scatter plot shift so that they now have a negative association with each other. And remember, the numerical value tells you the strength of the association. So the one I'm sitting on right now is a negative 0.7. Of course, you know -1 is a perfect negative association, and that's what a -1 would look like. So you can slide the slider, and that's like a negative 0.9. So you can kind of get a feel of what the points might look like with a specified correlation coefficient. If we take it back to 0 and then head in the positive direction, so there's 0 again. Now go to the right, and you'll see see how they're tilting into a positive association. So right now they have a 0.3 correlation coefficient. There's a 0.5, 0.6, and you can see how they're kind of starting to meld into a stronger line. So right now they're at 0.8, there's 0.9, and that would be a perfect positive association with a correlation coefficient of 1. So that's a really great applet for showing you that. So the second one we're going to look at is from the University of South Carolina. We've talked a little bit about outliers and influential points. Now we're going to talk about them a little bit more. So you might want to take note of the URL. So you can read the description up there. I'm going to slide down so you can see the bottom a little bit. There you go. So you'll notice that it's kind of preset for you. Just a simple line. You notice there's 4 points there. And if you take a look at the bottom, this particular line has a regression equation of 2.946 plus 0.97958x. and a correlation coefficient value of approximately 0.998, so a pretty strong positive linear correlation in this case. You'll notice that the directions at the top tell you what I'm going to be walking you through. Basically, what you can do is you can start clicking anywhere in this graph to add a point, and you'll notice that when you add it, it adds in red. And you'll notice also that the line, the linear equation, and the correlation coefficient change. All right, so I just kind of clicked right there. You can see my little red point, and it redrew the regression line to account for that 5th red point that I just put in place. And now there's you'll notice a lower correlation coefficient. All right, so maybe if I click up here, all right, notice you can only add one red point at a time. All right, and now you can see what the correlation coefficient is now. Notice how the R is a little bit better than the first time I had it in place. Okay, this is a really great applet for demonstrating to you the difference between an outlier and an influential point. We've talked about how outliers kind of hit you in the face and they're just kind of far away from everything else. So on this graph, unfortunately, you can only go kind of so far. So if we were to put, like, I'm going to try to put a red dot here in kind of the far upper right corner, like right there, see? All right, see how it does kind of lie, well, it's about as far as I could get it from the other points. But notice how it's still sort of in line with the other points in the scatter plot. And take a look at both the regression equation and the correlation coefficient. Notice how the correlation coefficient didn't change that much. Neither did the slope of the regression equation. That's what an outlier does. It's going to be far kind of lying away from everything else. But typically an outlier will still be falling into line with the other existing points. It's not going to change your correlation coefficient or the slope of the regression line very much at all. Contrast that to an influential point. Influential points can often be outliers, but an outlier does not necessarily have to be an influential point. I'm sure you've learned in geometry, you know, every square is a rectangle, but not every rectangle is a square. I'm sure you remember hearing that. It's kind of the same thing with influential points and outliers. Influential points do tend to be outliers, but not all outliers are influential points. This is an example, this one that I put in place, of an outlier that is not really an influential point because it did not really change the correlation coefficient, nor did it change the slope of the regression equation. All right, let me put a point all the way down here in the lower right. All right, that guy is really far away from everybody else, very much out of line with the existing points. And notice how much putting that point in place changed the correlation coefficient and the slope of the regression line, even in this case the y-intercept. But usually we look at the slope. That's an influential point. An influential point is going to dramatically change not only the correlation coefficient, but the regression line itself. All right, I could put an influential point all the way up here, maybe like in the upper left corner, like that. All right, notice it had a similar impact as that last point on the correlation coefficient and the slope. It is even possible, depending upon the existing points, that a certain influential point could make it into a negative association as opposed to a positive association, or vice versa. All right, so when we talk about an influential point, it can really, really make a difference. All right, so play a little bit with this because you will need to know the difference between an outlier and an influential point. And I think this applet is a really good one to demonstrate that and help you visualize it. So again, to recap, an outlier tends to lie in line with the other points, like maybe that one. That looks a little bit farther away than the other one. But an outlier often will not change much the correlation coefficient or the slope of the regression equation. An influential point, on the other hand, will change both the correlation coefficient and the slope of the regression equation. All right, the third applet. This is one that we've seen before. This is the one that permits you to match the graph to different correlation coefficients. And every student gets a different one, so this is a fun one. Again, take note of the URL. So you might not have the same graphs I do. Just FYI. These are the ones I got. You'll notice if you take a look at the graphs you have, you should notice on your graphs all the correlation coefficients in these 4 problems are the same. What changes is the graph. All right. So, for instance, in the ones I got, this top left one, Definitely a negative association. Pretty strong because they're kind of nice packed together. So I'm guessing that's going to be a negative 0.93. This one to the right, that does look like it's a negative correlation as well, but not as tightly packed as the other one. So I'm guessing that's going to be the negative 0.43. If I come down here, both of these are positive, but you can see the one on the left is definitely, again, packed a little bit tighter than the ones on the right. So I'm thinking that's that, and that's that. You can check your answers, and you get good, funny, funky looking smiley faces if you're right. So definitely play with that, because that's a great exercise, and something you could even see in the AP on the multiple choice. They'll sometimes do problems like this. So you definitely want to have a feel for what a given graph and its correlation coefficient might be. And that brings us to the final applet that I'm going to share with you. This is one from the textbook we use, The Practice of Statistics, 3rd edition. And if you go to the textbook website, you'll want to choose Statistical Applets under Student Resources. You do not have to log in for this, as you do when you take the practice quizzes. It might take a second to render, so just give it a minute. I actually already had these loaded up and it's still taking time. But once you get to the next page of all the applets, you're going to want to choose the one that says Correlation and Regression Applet. You'll see it in the left column. There we go. If you find that on your computer it just keeps cycling and cycling, try hitting the stop button up there on your URL. I'm in Firefox on a Mac, but right here there's a little circle kind of cycling icon. While it's trying to load, if you're noticing it's taking a long time, it'll look like an X there while it's trying to load. Just kind of like stop it midstream and it might render then. Alright, so the one you want to select, it's the third one down in the left column. It says Correlation and Regression. Just click on that. And they give you the write-up at the top, so let me scroll down a little bit. And there isn't really anything there. There's not supposed to be. Okay. What you need to do is make sure this is bulleted right here where it says Add Data. What you want to do is basically you add the points, and then you can kind of change up what the points look like, and it will generate for you the least squares regression line, and you can have it draw the line, and you'll notice the correlation coefficient. This is a great exercise in you practicing putting together your own scatter plot that has like a target correlation coefficient. So for example, maybe I wanted to put together a scatter plot that would look like it had a correlation coefficient of 0.9. Okay, so you just start clicking, and you'll notice, keep your eye on the correlation coefficient. It actually changes as you add points. Oh, there, now I got 0.9 about. So you can almost try to maybe minimize how many points you need to get to a target correlation coefficient. You can check the box to show least squares regression line if you'd like to see the line that it forms. We'll be coming back to this later in one of the later lessons. You can hit the trash can and start over. Alright, so maybe I wanted to have like a negative 0.7 now. Alright, so just start clicking. Oh, I just almost had a 0.7. There, that's close. That's a little bit closer. So this is a neat exercise, and it's sort of a game with yourself. You pick a correlation coefficient that you want to target and see if you can come up with a scatter plot that has that designated correlation coefficient. So that's all I had for you in terms of the applets. So please do play with those, because correlation is really something you want to have a good feel for, and these applets do a great job in enabling you to get to that point.